Hello, my name is Philippa, and this is my Lab 4 Physics period of oscillation lab. Okay, so the introduction of this lab is the purpose is to use a spring mass system to show oscillation to observe the energy principle in Newton's second law, and then compare that data in tracker versus glow script, aka looking at an ideal model versus a real world model. And here are the relevant equations. As you can see, we have change in potential gravity, energy, change in the energy of a spring system with the force of a spring system. You have the change in kinetic energy, F net equation, velocity final equation, and change in position equation, as well as an equation showing how the change in the energy of a system equals work. So what is the energy principle? Energy can neither be created nor destroyed, just transferred to one type of energy to another. And the change in energy of a system is equal to the work done by the surroundings, including thermal energy, which is not being used in this lab. So the procedure for this lab, first let's identify the systems and surroundings. So system is mass, the spring, and the earth and surroundings are none. So that way that we can make work equal to 0. Procedure is import video into tracker, define origin and track the spring's motion using tracker, export data into Excel, and then import data into GlowScript, and compare and graph the experimental model, GlowScript, versus the real-world model, Tracker. Okay, here's my tracker data. As you can see, it's not quite even. This is probably due to a tracking error. My point mass system is probably not completely even, but here it shows that the total time of the video was 9.11 seconds, which can then be used to find the period of oscillation and also the spring constant, as well as LO. Okay, and so here are my initial conditions, as you can see, and here are my calculations for the spring constant. And then I also have the ball mass, which was 0.420 kilograms, and my ball's initial position, which I got from my tracker data. Okay, and here are my GlowScript computational models. As you can see, here is all my calculations to actually determine what the graph would look like at the end. Okay, and then here are more of my calculations, as you can see. And here are my graphs in GlowScript. As you can see, the times are like not quite even. This is probably due to errors that we will discuss later on in the video. Okay. Possible errors. My real life model is choppier due to incorrect tracking. Graph and tracker is less even due to that. And work being done by the surroundings. This could come in the form of air resistance or drag. Obviously, in our ideal system, there is no work done by the surroundings, but we often know in real life that's not possible. So was the energy principle followed? Yes. The total change in the energy of the system equaled 0. As you can see in this graph here, delta E is consistently 0, meaning that the energy principle was followed as there are no external forces doing work on the system. Spring and gravitational energies are opposite of each other. And when delta K equals 0, U grav is at its max, which makes sense as we know when delta K increases, U grav decreases, and when delta K decreases, U grav increases. Okay. Thank you. That'll be all today.